All right, kiddos, we have made it to slide number 14. And we're getting ready to talk about the really confusing part of the autonomic nervous system. And maybe you say it's already confusing, but don't you worry, it's going to get even more confusing. You will see. It's because we're going to talk about how all of these different neurotransmitter substances, and depending on the receptor, it's going to have a different response. So the post-ganglionic neuron, or the effector, is going to be affected differently by the same neurotransmitter substance, depending on what kind of receptor we're talking about. And not only is it somewhat confusing that way, this is really important because why? It's because this is where a lot of physiology, where we want to control physiology in medicine. So most everyone here in this class has an interest in some kind of medical field. And so whenever we talk about controlling things like hypertension, you'll recognize some of the ways that we control things like hypertension when we talk about different sympathetic division receptors, alpha and beta receptors. So you may have heard of alpha blockers and beta blockers. This is where we're going with this. Okay, so slide number 14. This is where, so the effect, slide number 14 says that the effect is determined by the type of neurotransmitter which is released and by the receptor present on the target cell, either the post-ganglionic neuron or the effector itself. One other generalization that we can make that's related to these neurotransmitters is that the effect of the sympathetic division is longer lasting. So the neurotransmitters, substances that are used by the sympathetic division, are going to persist longer in the synapses, and in some cases they're going to be secreted into the circulatory system. So obviously we're going to be talking about a longer term effect if it's in circulation. So let me see. Okay, so one of our favorite neurotransmitter substances is going to be acetylcholine. We've been talking about that since last semester, right? We had said the primary neurotransmitter substance associated with muscle contraction is going to be acetylcholine, right? Well, for the parasympathetic division, it's also going to be the primary neurotransmitter substance. And it is sometimes used by the sympathetic division. Isn't this fun? Okay, so when we talk about the autonomic nervous system and the receptor types that come into play with the neurotransmitter substance acetylcholine, and what we refer to this type of the receptors for acetylcholine, we just call them cholinergic receptors. And so one of them is called the nicotinic receptor. And so what does that sound like? Cigarettes, right? Nicotine. And it's not because it has nicotine in there. It is because that the toxin nicotine will also stimulate this receptor. So they named these receptors based on that kind of thing. At least this one and the next one we'll talk about. So the nicotinic receptors, basically all in that first synapse in the at the ganglion, we're going to see acetylcholine with nicotinic receptors. And what is the effect? excitatory. And that's always going to be the case. And if you think about it, well, it'd be kind of stupid to send a signal to a ganglion that was inhibitory, and so then nothing would happen, right? Let's control physiology, and the signal goes out to the ganglion and stops. So here at that ganglion, whether we're talking about the parasympathetic division or the sympathetic division, the neurotransmitter substance and the receptor that is used in this synapse will be acetylcholine with nicotinic receptor. And so it is always excitatory and sends the signal on, stimulates the post-ganglionic neuron. Now, when both the sympathetic division and the parasympathetic division, you'll see acetylcholine. It's through all of the parasympathetic division, the post-ganglionic neuron. So the second neuron is also going to secrete acetylcholine. But we have another kind of receptor, which is called a muscarinic receptor. And this was identified from a type of a fungal toxin, and that's where it gets its name. And so the muscarinic receptors can either be excitatory or inhibitory. So acetylcholine in the post-ganglionic neuron can go out to an effector and either increase the activity of the effector or decrease the activity of the effector using the muscarinic receptors, and sometimes it will result in an inhibitory effect, and in other cases, an excitatory effect. And so it has to do with what goes on inside of the cell after it is stimulated. And so it's either can be inhibitory or excitatory. All right. So when we look at this drawing right here, you can see here we can see parasympathetic division. We had said here we are at the ganglion here, and we had said this is a nicotinic receptor here, and then at the effector it can be this other kind of receptor, muscarinic, or in this case, we're talking about muscarinic receptor. So it can either be excitatory or inhibitory. Then when we talk about the sympathetic division, we can see that the acetylcholine, we had said it is always the neurotransmitter substance that is going to be at the ganglion, and we had said you're always going to have this nicotinic receptor there. But then you notice that we have other kinds of neurotransmitter substances. The primary one for the sympathetic division is not going to be acetylcholine. It is going to be something called norepinephrine. And norepinephrine is the most common neurotransmitter substance used at the effector when we talk about the sympathetic division. Now, when we talk about the receptors for norepinephrine, this is where we get into that alpha and beta thing. I'm sure any of you have worked around nursing homes or, as CNAs, or maybe you're in the nursing program or you just love medicine. You would know about alpha blockers and beta blockers and all of this kind of stuff. Well, these can either be, like that muscarinic receptor, they can be either inhibitory or excitatory. And so when we talk about the heart and blood vessels, for the sympathetic division, it's going to involve norepinephrine and either alpha or beta receptors, and they can either be inhibitory or excitatory. Now, when we talk about the heart and blood vessels with the parasympathetic division, it's acetylcholine with the muscarinic receptor. And again, this can either be excitatory or inhibitory. All right. Now, there are some cases, the sweat glands, and in some cases with blood vessels, the sympathetic division is going to use acetylcholine with a muscarinic receptor. Now, in other cases, we have a different final neurotransmitter substance. We had said that here we're looking at dopamine. So blood vessels of the kidneys, renal blood vessels, are controlled with dopamine for the sympathetic division. And then we had said that we had this one weird exception where we just have the preganglionic neuron, and we said that's going to the adrenal gland, and what is its effect? It's going to be it's going to either be sending the adrenal glands will then communicate with blood vessels via norepinephrine. But the adrenal glands are going to be stimulated by acetylcholine with a nicotinic receptor. Okay, so it's complicated, right? So one of the places, if you know anything, oftentimes with medicine in general, people's physiology, they get locked into a box. They have one problem that is treatment of that problem is contradictory to treatment of another problem. An example of that would be a person with hypertension and asthma. It ends up, you can use a beta blocker to limit the effects of norepinephrine on the blood vessels, so that to treat hypertension. And so the norepinephrine will combine with the beta receptor, and it's going to cause the blood vessel to constrict, to become smaller. And so you say, well, so you can use a beta blocker, and you can say, you can make the blood vessel larger. And what does that do? That increases the diameter of the blood vessel, so you have lower pressure. Well, with asthma, you want to have that same effect on the bronchioles, but it ends up the beta blockers actually cause the bronchioles to become even more constricted. So this is an example of how if a person has asthma, they can't use a beta blocker to treat their high blood pressure. That's one of these examples of ways that we can get painted into a corner. All right, so I've gone 13 minutes. I need to stop right now, and we'll come on back and talk some more. Talk to you in a minute.